Bismillahirrahmanirrahim. Assalamu alaikum dear students. I am Arif and I welcome you all to the next session on the subject of system programming with Linux. Well, today we are going to see how a C program starts and how it terminates. We'll talk about normal and abnormal termination. We'll talk about the exit handlers and registering the exit handlers using atexit and OnExit calls. And finally, we will talk about process resource limits. Okay. Well, this slide shows you how a C program starts and terminates. Well, when a user tries to execute a binary on a terminal, the shell forks a child shell, which is of course a clone of the parent. That is, the child program has the parent program loaded in it. The operating system kernel then uses the exec system call to load the binary program in the address space of that process. Then the addresses of various dynamic libraries or shared objects that are already loaded for other processes are memory mapped into the address space of this process, which is shown over here as different C startup routines. These C startup routines also contain code to set the command line arguments and environment variables in the process stack, and then the main function is called over here. The main function then calls other user-defined functions, it returns, and this process goes on. And finally, either the main function calls the return statement or the exit function, or any of the user-defined function call the exit library call. And the program terminates. Let us move on to the terminal and understand this part first. Let me get a program. Okay. Well, this is a very basic program which is calling a function display and passing a string to it. And this display function is receiving that string and printing it on the stdout using printf function, and falls back to the main, and the main terminates by the return statement passing 54 to it. We can always use exit 54 over here. And why I've used 54 not 0, I will talk about this soon. Let me compile this program gcc proc1.c and let me execute it. Okay, and let me use strace command. Strace command is used to monitor the system calls made by a process and also the signals sent to it. Strace ./a.out, and let me shrink the screen a little bit. Okay. So over here you can see this strace call has traced all the system calls that this process has made, and the first call is the exec ve call with the arguments written over here, and this 0 is the return value showing the success status. Then you can see various other calls like the memory map calls along with open, access, and the read system calls. And about these we will of course discuss in later session. So these are going to memory map different shared objects onto this process address space. And finally this brk is going to lay out the heap for this process, and this is actually the only line of execution that is used, and that is basically the printf statement that is converted to the right system call and writing this string on stdout, that is file descriptor 1, and this is the third argument to write, that is 26 characters. And finally this 54 is the exit value. And if I do echo $, you can see the exit value is 54 over here. Let me clear screen and let me increase the font size a little bit. And let me move back to the slides again. Okay, so we have seen what all system calls or the startup routines are called before the main function is actually called, and the main function called different user functions, and then either the user function or the main function call the exit library call, or the main function calls the return statement and the program exits, and the exit value is passed to the parent, and that is a shell. Well, this exit function actually causes normal process termination, and now let's talk about what exit function do before terminating the process. Well, the exit function call some standard I/O cleanup routines, which actually flushes the I/O buffers and closes all the open files. Other than these, the exit function also call various registered exit handlers. An exit handler is actually a programmer supplied function that is registered at some point during the life of the process, and it is then automatically called during the normal process termination. So once you call the exit function, your process called the exit function automatically calls the standard IO cleanup functions as well as these registered exit handlers, and then it returns that integer value to its parent. So if a programmer wants to perform some task automatically on process termination, he or she will write the code to perform these tasks in functions, and these functions are called exit handlers. Let me move on to the terminal and understand this. Let me see the man page of atexit. Okay. Well, to register a function as an exit handler, we can use this atexit library call, which is passed a function pointer as argument. And we know that a pointer that stores the address of a function is called function pointer or pointer to function. And this function over here, this one, function, this is a function pointer that can point to any function that is passed nothing and it returns nothing. Do see the man page in detail. Let me show you a sample program that use this atexit call to register exit handlers. Okay, fine. It's a very basic piece of code. Over here in the main, you can see the atexit call, which is passed the name of a function, and the name of the function is exit underscore handler. It can be any name, f1, f2, f3, f4, whatever. And this is a function, and inside this function we can write down any code, but right now I'm just writing printf exit handler. And this is the printf function, and this is the return statement, or you can use exit 0 or whatever over here. So normally once this program will execute, we will say that it will print just one line, that is main is done. But however, when we compile this program and execute it, it says main is done, and then it says exit handler. Actually, when main is done and it calls the return statement or the exit function call, the exit function before exiting or terminating the process calls the exit handler. The exit handler executes and then the program terminates. And this is what is happening over here. Let me use the underscore exit call to Instead of using exit, let me use the underscore exit call. Let me save and exit. Let me compile this program and let me execute it now. You can see the exit handler is not called now. Okay, if any of the function, either the main or any user defined function, quits the program by underscore exit or underscore exit with a capital E, the exit handlers are not called. It terminates immediately. Exit handlers are only called if the program is closed with normal termination, either by the return statement by the main or exit function by the user function. Another point to note that you can see more than one exit handlers over here. So you can register more than one exit handler, or you can always register one function more than one times. POSIX, Portable Operating System Interface Standard, actually allows registration of 32 exit handlers using the atexit call. In case of more than one exit handlers, they are called in the reverse order of their registration. Let us confirm this point as well over here. And we have another example code to prove this concept. Over here we have two exit handlers, myExit1 which is saying first exit handler, myExit2 that is saying second exit handler. And inside the main I am first registering myExit1, then again myExit1, then myExit2, and then I am saying main is done. So once we will compile this program and execute it, the first line that will be printed is main is done. And the second line will be these exit handlers will be called in the reverse order of their registration. So after main is done, we will have the output as second exit handler, then first exit handler, and then again first exit handler. Let me compile this second example. Let me execute this, and there you go. So that point is also confirmed that in case of more than one exit handlers, they are called in the reverse order of their registration. Okay, I think I've covered every aspect of this diagram. Let's move ahead. Well, this slide shows the normal and abnormal termination. As far as the abnormal termination is concerned, we will talk about it when we will be talking about signals. Okay, so this slide shows you the limitation of atexit call. Well, dear students, an exit handler doesn't know what exit status was passed to exit, which may be useful. For example, we may like to perform different actions depending on whether the process is exiting successfully or unsuccessfully. Let me keep sipping a cup of tea as I had a very long day today. Anyway, the second limitation of exit handler is we can't specify an argument to exit handler when called, which may be useful to define an exit handler that performs different actions depending on its argument. Well, in order to understand these two limitations, let me move on to the slides again. And let me use another function that is on_exit. This is another function that can be used to overcome these limitations. Let me move over here and see, do I have a slide for this? Yes. Well, this onExit is another function that you can use to register your exit handlers other than atexit. The onExit is a powerful variant of atexit. It accepts two arguments. The first argument is a function pointer that is passed two arguments, an integer and a void pointer, and it returns nothing. The second argument to OnExit is again a void pointer. Okay, let me move back over here. Do read this man page at the time of your ease. Let me move on to the example straight away that will explain these concepts. Okay, we have a function myExit, which is passed an integer value and a void pointer. So myExit can be used as an exit handler that can be registered using OnExit, because remember, OnExit is passed two arguments. The first is a function pointer that is passed two arguments, an integer and a void pointer, and it returns nothing. So this is the first argument to OnExit, our exit handler, and this is the second argument that we have passed to it, that is 7. And over here we have both the exit status as well and the value 7 as well. So the output of this program is this line will be printed, and since we have only one exit handler, this will be called, and this will be called with this value 54 over here and this 7 over here. So it will print exit handler called with exit status 7 and argument exit status 54 and argument 7. Let's see this. GCC OnExit ./a.out. Okay, so that's great. So using OnExit, we can overcome the limitations that are there in atexit call. So far, so good. Let us move back onto the slides. And now is the last part of today's session, and that is process resource limits. Well, dear students, every process has a set of resource limits that can be used to restrict the amounts of various system resources that the process may consume. We can view as well as set the resource limits of the shell or a terminal using the ulimit built-in command. These limits are inherited by the processes that the shell creates to execute user command. And since kernel 2.6.24, the Linux specific file, that is proc PID limits, can be used to view all the resource limits of any process. Let's move on to the terminal and see. And let me do a cat first of the file inside the proc directory. I assume a process with an ID of 2 is there, and it has a file limits. Okay, so it shows you 4 columns. The first column is the resource limit, for example, maximum CPU time, and this is the soft limit, this is the hard limit, and these are the units in which it is mentioned. Well, CPU time is the maximum number of CPU time in seconds that can be used by a process, and it says its soft and hard limits are both unlimited. Okay, see this line. Maximum processes. So maximum process is a limit that means how many child processes a parent can create. So this is the soft and the hard limit. Let me describe this line as well. Max open files. Max open files means the maximum number of files the process can open at any one time. The soft limit is 1024, the hard limit is 4096. Well, the soft limit is actually the value that the kernel enforces for that particular resource, while the hard limit is the upper limit or the ceiling for that limit. And you cannot increase the soft limit above this limit. Let me also use the ulimit command, and this also shows you the limits of different resources. Like over here you can see open files 1024, and this pipe size is 8 and the unit is 512 bytes, that means 4 KB maximum pipe size. The way we can check these limits on the shell using the ulimit command and by viewing the limits file inside the PID directory of every process. We can also get and set these limits using functions like the get R limit and the set R limit. Let me do that as well. Man get R limit. Let me see the man page of this. Okay. So these getters and setters are passed actually two arguments, the resource and a structure. Well, this resource can be a constant, mostly a constant that describes the specific resource you want to query about, and this structure is shown over here down. Yes, over here the structure is shown. We pass a pointer to this R limit structure, and it is after the successful call to get R limit. This structure is populated with the soft as well as the hard limit for that particular resource. Let us let us use this get R limit function to get the soft and hard limit on the number of files that a process can open at any one time. And along with many other programs, I have written this program as well. Okay, so this is the program which is using get R limit to populate this struct R limit structure, and this is the constant I'm passing. This R limit underscore no file is a constant used for querying the number of files that a process can open at any one time. Other constants can be R limit CPU for querying the CPU time, R limit data for querying the data section initialized plus non-initialized data section. Over here you are seeing these if-else structures. Well, we use these if-else structure to find out whether the value of the limit is infinity or otherwise, because you might have observed using the previous commands that some of the resources have the value infinity. So if it has a value of infinity, it will print infinity. Otherwise, this member of the limit structure will print the actual value. Let me compile this. Let me execute this. And you can see the soft limit and the hard limit for the number of files 1024 and 4096. Let us confirm this with the cat command as well. Let me clear screen and let me use the cat command as well to find out the values from here. Let me grab open files and find. You can see this is the resource, this is the soft limit, this is the upper limit, and this is the unit. Okay, let me use another command, get conf, and let me use the constant open underscore max for this, and this will show you the soft limit. So you can see the man page for get conf and for this proc directory in details for other constant values and how to find out and change the values of these resources and these limits. Okay. So dear students, that is all for this session. Do practice the concepts by running the code snippets and making minor modifications to them. It will be fun. If you have liked it, please do subscribe my YouTube channel and share it with your friends. I wish you all the best. Happy learning and Allah Hafiz.